Waves are used to transport energy from one place to another. You won't be asked to recall this exact definition, but you'll learn about many types of waves at GCSE. For example, light waves, seismic waves, even a wave made on a rope. These are all ways of transporting energy. Speakers also work by producing waves. This type of wave can be represented by drawing a pattern like this one. The speaker gives out energy, which is transported in this sound wave to our ear. Our ear then receives this energy, causing bones in the ear to vibrate. Certain waves can also transport information. Now, the ear mostly uses these sound waves to tell the brain about what kind of noise the speaker is producing, whether it's loud or quiet, low-pitched or high-pitched, etc. This is only a secondary effect of the wave, though. Its main purpose is to carry the energy from the speaker. Let's take another look at a simple example of a wave. Here we see a raindrop landing on a body of water, which will produce ripples on the surface of the water. These are water waves. Since we see the ripples moving outward, we know the wave is moving out and away from where the drop hit the water. The purpose of this wave is to transport energy. In this case, when the drop hits the water, it transfers its kinetic energy to it. The water wave carries this kinetic energy and spreads it out across the water. You could also say that the waves tell us something has disturbed the water, but you normally wouldn't consider this as an example of a wave transporting information. But how exactly is the wave moving, and what happens to the water as it does so? Well, first we'll need to know this key definition. Mechanical waves are transported through the movement of matter. Now, mechanical waves consist of all types of waves except what we call electromagnetic or EM waves. Light is an example of an EM wave, but we'll be looking more closely at that elsewhere. For now, let's go back to our sound wave. We can visualize the motion of a sound wave like this, where the circles represent the air molecules the waves move through. Because the waves travel through the movement of this matter, it's a mechanical wave. As we can see, the wave travels in this direction, as this is how the energy is moving through the molecules. Once the energy reaches a molecule, it causes it to move, which then causes the next molecule to receive energy and also move. However, as the wave is transported, none of the matter will move permanently. This is a rule that applies to all waves, not just mechanical ones. In a non-mechanical wave, this must be true, as the matter wouldn't be moving at all. It's a little trickier to understand how this works in a mechanical wave, so let's understand by looking more closely at our sound wave. As we can see, as the wave reaches the particles, it causes them to move back and forth. However, once the wave has passed, they are still again. They've received the energy from the wave and given it all to the next molecule to keep the wave moving. Most importantly, they are now back in their original position. There has been no overall motion.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!